also look at the row. Is it, but you can see both. Okay, but you can look between them easier.
So today's lesson, section 1.4, rewriting equations and formulas. So our only definition that we have, only vocab word from this section is a literal equation. A literal equation has two or more variables. Remember, we use letters to represent those variables. And so geometry formulas are examples of literal equations. For example, last chapter, we used this formula to find the area of a, what? Carson? Triangle, yeah. Or we used this formula to find the surface area of a, Xander? Cylinder. Or we used this formula to find the volume of a, Sean? Sphere. These are all literal formulas or literal equations. To be a literal equation just means you have two or more variables. The last one I wrote only has two, so it barely qualifies, even though it looks like pi might be a variable. Pi is a number. The one before that actually has 1, 2, 3, 4. And if we're getting technical, capital B has more variables that can go inside that depending on what your base shape is. Okay, so these are all literal. We'll look at more of these later. The biggest thing I want you guys to gather from this lesson, though, is something we're going to be doing in a couple chapters. In chapter 4, we're going to have to take equations that look like this and solve them for y. When you solve an equation for a variable, that means you're getting that variable by itself. It doesn't necessarily mean you're going to be given just an integer answer. Normally, when I solve an equation, I get something like x equals 2. When I solve these, I will not get x equals 2 because I don't have all the necessary information. I have two variables instead of one. So to solve an equation for y, which is always the variable we're going to solve for, to solve it for y, we just have to get y by itself. So I want you to imagine that this x variable is just any other number. And if it was any other number, we'd want to go ahead and get rid of that. And so if I'm solving for y, the first thing I would do is get rid of my 5x term. How do I get rid of my 5x term, Lizzie?
Divide 5 from both sides.
Not divide 5. That would just get rid of the 5. How do I get rid of the 5 and the x? Subtract it. So I'm going to subtract 5x from both sides. Now that's going to get rid of that 5x from the left side and move it over to the right side as a negative 5x. When you're writing this down, I would strongly encourage you to write the negative 5x in front of the positive 6. So instead of 6 minus 5x, write negative 5x plus 6. The reason for that is because in chapter 4, when we're doing this all the time, there's a certain formula that you're going to want to match that looks like this. That formula, I'm not even going to explain to you what it means right now because you don't need to know what it means right now. But if you look at it, that formula has the x term written first. So we want to make sure our x term is written first. And it's a bad habit to get into if you just always write the constant term first because your equation would always be backwards. So when you subtract 5x, put that right in front of the 6. So negative 5x plus 6. Oops, let's erase that out. You get the door for me. Oh. Now to get y by itself, what would I do? Jimmy? That's right, divide it by 2. So I'm going to divide both sides by 2. And when I say both sides by 2, I mean every term on both sides gets divided by 2. So 2y divided by 2 is just 1y, or y. Negative 5x divided by 2 turns into the fraction negative 5 halves, or you can write it as a decimal negative 2.5. That works as well. And then what's 6 divided by 2? John? 3. That's my answer. I can't do anything else with it because I don't know what X is. Until someone tells me what to plug in for X, I can't actually tell you what that number times -5/2 plus 3 would be. So this is solve for Y. When you solve an equation for Y, you're just getting that variable by itself. We have accomplished that goal. It doesn't look very nice, but we've accomplished that goal. Y is by itself. So we're done. Xander.
Could you write -5/2 is -2.5x?
Yes.
Okay.
-2.5x or -2.5x or -5/2x. I would accept all of them. I'm sure big ideas would too, but you know how they are. So if it doesn't accept one, try a different form of that. The mixed number might get a little hairy, but yeah, it should accept that.
Okay.
Look at example B. 5y minus x equals 10. I'm always solving for y, which means I need to always move my x term to the other side. Connor, how do I move this x term to the other side? Perfect. And because I want to always write my variable term first, instead of writing 10 plus x, we're going to write x plus 10. And then just have the 5y on the other side. Christian, how do I get y by itself now? Perfect. Yep. And both sides by 5 means every term on both sides by 5. So that's going to give us y equals, there's a 1 here. So we can write that as 1/5 x. And then 10 divided by 5 is what, Chloe? So y equals 1/5 x plus 2. That's it. There's nothing else we can do. Try this one on your own. In fact, once you try that one, you can move on to example D. Give you guys some time to do that. If you're watching at home, you can fast forward to when we're ready to go over them.
No, it wasn't.
Oh my gosh. Pardon. Maybe a hint on that first one there. When you move the 4x term over the other side, make sure you have -4y, not just 4y. Right. So forget that minus sign for the negative sign. This will be a very useful skill in our upcoming chapter. You're like, how could this possibly be beneficial? Well, it'll all make sense to you. Start graphing these equations. And I don't mean like the inequalities that we're going to graph next chapter. I mean, we're going to turn these equations into lines. We're going to graph lines. Because the coordinate plane is made up of 2 axes. You know what they are? X-axis, y-axis. What 2 variables do they have? Yep. So these equations can be turned and plotted into points, and those points will form a line. And basically, I've given away everything we're going to do for the next half of the school year.
Oh, thanks.
Yeah. This is pre-algebra, and what you're looking at is algebra.
So we've learned it now. So-
You learned it now, so I don't have to teach you, right? Jace?
Why is it called X and Y?
Why are the X and Y axis? I'm not sure. I know that you can graph in 3 dimensions, and there's an X, Y, and Z axis if you graph in 3 dimensions. When you, no, we won't. When you get into high school, you might. And actually, if you want to do anything with architecture, or if you like doing blueprints are always 2-dimensional, but when you use programs like Solid Edge, where you graph things in 3 dimensions, or you construct a house, for example, a 3-dimensional model of the house, you would graph X, Y, and Z axis. So I don't know if why, maybe that's just why they use the last 3 letters of the alphabet. But All right, example C. Barton, what was the first thing you did? Perfect. And what did that give you?
Negative 4x plus 1 equals negative 4y.
Okay. I'm gonna write a little bit backwards from what you said. Negative 4x plus 1 equals negative 4y, or negative 4y equals negative 4x plus 1. Thank you for writing the variable term in front of the 1, which is just a 1, so we're gonna plus 1 because it's positive. Lucy, what's the next thing we would do? What's the negative 4 doing to the y? So we're going, yes, we're going to divide everything by negative 4. And when I say everything, I mean everything, right? Both sides, every term on both sides. So the negative 4s are going to cancel out, leaving you y equals. The other negative 4s are going to cancel out, leaving you x. And then how would I write positive 1 divided by negative 4? Negative what?
Negative 1/4 x.
No x, just negative 1/4. Yep. Positive 1 divided by negative 4 is just the fraction negative 1/4 or minus 1/4. Or you could put minus 0.25 if you want to turn it to a decimal. That's going to take extra work. You don't have to do that. Did anyone get started on the second example? Lizzie, what's the first thing you did?
Subtracted 6x from both sides.
Perfect. Yeah, we want to get y by itself. I typically write y as on the left side. It doesn't have to be on the left side. It can be on the right side, but we definitely have to move the x term away from it. So what did that give you when you did that?
Negative 6x plus 12 equals 31.
Perfect. So by eliminating the 6x term from the left side of the equation, right side of the equation, this one's backwards. Now we just have the y term on the right side, and on the left side, it's now a negative 6x plus 12. Okay. Brady, what would be our second and final step here? Nope, I want to get y by itself. So now that I've got the y term by itself, let's get rid of the coefficient. What's the coefficient next to the y? It would be, yep. That 3 is being multiplied, so we are going to divide both sides, or every term on both sides, by 3. And Brady, what would that give you? By the way, I'm just going to go ahead and flip it around, put y equals on this side.
Y equals negative 2x plus 4.
Got it. Got it. Okay. Good. Because I like most of the homework, just that. All right. Now we're going to get into some geometry formulas because it says we're supposed to rewrite equations and formulas. So now we're going to do the formulas part. The formula for the surface area of a cone is S equals pi r squared plus pi r L. You might also recognize it as S equals B plus 1/2 CL. That's the one I actually gave you. But before I gave you that, we actually, if I still have it on here, I'm sure I do. I think we did that. Surface area of spheres. No, cones. Cones. And I think we went over, yeah, that was one of them that I gave you before we ended up writing it like that. Because it was nice to write it in a similar way from the other surface area formulas that we had. It says solve the formula for the slant height L. So instead of solving for y, we're going to solve for L in this one. I'm going to go ahead and write the formula down. Pi r squared plus pi r L. Want to solve it for L. So the second term I have over here, that pi r L, that's my L term. The other term doesn't have an L. Just like when we solved for y, this term didn't have a y, it had an x. So we got rid of it. We eliminated it. So we're going to eliminate the pi r squared term by subtracting pi r squared. So that's gone. Now we have S minus pi r squared equals pi r L. Now to get L by itself, we have to remove what from this equation? Lizzie? The pi r. So we're going to divide by pi r on both sides. And we're going to divide every term by pi r. I'm going to do that up here. That's going to give me L equals. I could write S divided by pi r. Well, actually, I'm going to do that because it'd be a lot more complicated. I wouldn't even be able to I wouldn't be able to write anything other than S if I didn't know what the surface area was. So I have to write S. Never mind. I was thinking we were going to substitute it for something that we can't. So S divided by pi r. That's a bad looking pi symbol. And then I'm going to divide pi r squared by pi r. Now, when you divide those, the pi's are going to simplify out or cancel out. What's r squared divided by r? Just r. Yeah, because r squared is r times r, and we're taking one of those r's away because we're dividing it. So it's just going to be r left. So L, that was minus r, wasn't it? Is now going to be equal to S divided by pi r minus r. I liked it better the other way. But do you remember problems where I gave you the volume and you had to work backwards to find the height? Or I gave you the surface area and had to work backwards to find the radius? Those kind of problems. That's exactly what this is. It may not look very nice, but if I would have given you all the numbers to plug in for that and asked you to find L, you would have done the exact same thing. You would have plugged in that, you would have subtracted that away, and you would have divided by whatever this would have given you. Next up, solve for the red variable. My spell check tells me that BH isn't a word. Somehow PRT is though. So anyways, what formula is this A equals BH? What is that, Deegan? Yeah, the area of a parallelogram or a rectangle or a square, but parallelogram incorporates all those things. So I want to solve for B. So Seth, tell me what I would need to do to both sides to solve for B. Remember, solving for a variable just means getting it by itself. So how would I get B by itself? Yes. How would I isolate the B? That's right. That's going to give you B equals, or you can write the B on either side, doesn't matter to me, capital A over H. When you do problems like this on big ideas, remember if a letter is capitalized, you need to mark it as capitalized when you're typing it in for your answer. So B equals capital A over H. So if I gave you the height and the area of a parallelogram, you would find its base by simply dividing those two. Area divided by height gives the base. What about I equals PRT? What is that used for? We haven't done that formula this year, but you did it last year. Xander?
Interest.
Yes, that's our simple interest formula. I stands for interest. What does R stand for? First one to shout it. Who said rate? Let's go. Sorry, first one to shout it. Another chance. What does the T stand for?
Time.
Time measured in years. T stands for time measured in years. What does P stand for? I heard it. I think it's you. Not perimeter. We're talking about simple interest. Power. P stands for principal. No, you cannot. I already said I. Oh, you did actually, yeah, you remembered the formula, so you should get one. Yeah, I didn't give any help for that. Simple interest formula. We'll talk about that a little bit more later this year. You guys don't do any percents in this textbook, but there's a lot of percents that are going to be on your 7th grade iLearn test. So during one of our success time activities, I might just have you guys in here and we'll work on problems like these that involve percents. Yeah. Basically, if someone said that you put a loan down or you had to borrow $4,000 from the bank to buy a used car, that would be your principal. And your interest rate, we'll say is 12.5%. So 12.5% as a decimal would be 0.125. And then your time, you're going to pay this loan off in 2 years. You would multiply 4,000 times 0.125 because 12.5% as a decimal times 2. And that would tell you what the interest is. And you have these fancy things called calculators that do a lot of that work for you. Martin, do you know what it is? Or you just stretch it? It's close, it's 1,000. Okay, it's $1,000. So then when I pay this loan off, I'm not going to pay back $1,000. That's the interest I'm going to have to pay. I'm going to have to pay back $5,000. So a $4,000 car in 2 years at that interest rate, it's going to cost me $5,000. The higher the principal, the more you have to pay back. The higher the interest rate, the more you have to pay back. The higher the loan amount, the more you have to pay back. So it's best to not borrow a lot, not borrow it for a long time, and to get the lowest interest rate possible. Okay, that's how you use simple interest. Credit cards don't use simple interest, but your mortgage on your house is simple interest. Your car loan is also simple interest. So there's a lot of things that you will do in life that use simple interest. And fortunately, you'll have people that can calculate that for you. And then you just have it paid out of your bank account. Yeah, Carson? Yeah, that's simple interest too. But the banks give you a very, very, very low interest rate. So you don't make very much money off that. Like my savings account is like 0.01%. So it's like, yeah, it's like they're barely giving you anything to keep your money. But when you borrow the money from them, they make you pay back. So it's the more that's in there, the more money you get because that percent of the higher number is going to be a larger amount. That's right. Yes. I multiplied P, R, and T all together. So I did 4,000 times 0.125 times 2, which gave me 1,000. And if your interest is $1,000, the amount you have to pay back for the loan is the 4,000 you borrowed plus the 1,000 in interest. That's how you figure out how much you're going to pay back total.
I did that, and I thought I was supposed to get 5,000 on it.
Yeah, no, you got 1,000, right? Yeah, okay. Anyways, we'll do more of that stuff later. You guys did that last year. I'm not sure how much time you spent on that last year. Week, okay. Okay, there's your formula. I want to solve it for capital P. So what do I need to get rid of if I'm going to solve it for capital P? What do you say, Carter?
R and T.
R and T. So R and T are being multiplied, so I'm going to divide. We're going to divide by RT. My guess is that when you guys were doing simple interest problems, you had ones where you had to find the interest, but you also had ones where you had to find P, R, and T individually, and this is what you did. Basically, you multiplied the two on this side you did have together, and then you divided it over. That's exactly what this says. P is going to be equal to the interest divided by the product of R and T. I know it doesn't look like we're done, but we are. We've solved that bit. We got it by itself, so it's solved. Don't have numbers, just solved. What is this formula for? You've done this problem this year, but this formula isn't one that I gave you. Where would I have to do 2 times pi r squared plus 2 times pi r h, Xander? Not a hemisphere. Lizzie? Not a regular sphere. Martin? A cylinder. This is the surface area of a cylinder. you might know it as 2b plus pH, I'm sorry, CH, because it's a cylinder. And remember, C is pi times D, and remember pi times D is the same as 2 pi R. That's where that's coming from, okay? So I want to solve all that mess for, I really don't like this new update. Every time I go to click my eraser, it pops that up, which I don't even know what that does. Not what I want it to do. Okay, so anyways, want to solve it for H. So I'm going to start off by getting rid of the term that doesn't even have an H, which is the 2 pi R squared. And I'm going to eliminate that by subtracting it. I'm not dividing it. I'm subtracting it because it's being added to that term. So I'm taking it away, right? It's positive. So I'm going to subtract, throw a negative 2 pi R squared up there, and it cancels out. But I have to do it to both sides. That's going to give me S minus 2 pi R squared equals 2 pi R H. I want to solve for H. So just like last time, I'm going to have to divide, but there's 3 numbers that I need to get rid of: the 2, the pi, and the R. So I'm going to divide by all of them. And that means I'm going to divide each term by 2 pi R. So when you divide both sides by a number, or in this case 2 pi R, you have to divide each term on both sides. So that's going to go away, leaving me with H equals S divided by 2 pi R minus, what's left? Lucy? Not 2 pi R. This is going to cancel, a lot of this is going to cancel away. Keep going. What's left? Sky, help her out.
R.
Just R. Just R. So the 2's cancel out, the pi's cancel out, and remember, like last time, this is pi, this is R squared. Divide R squared by part R to the first power, and you're just left with R. So S divided by 2 pi R, S over 2 pi R minus R equals H. And as crazy as that seems, you've done a problem like that, because I remember specifically giving you a cylinder and asking you to find the height of it given its surface area and its radius. So you may not have done it exactly like that, but you've done those same steps just with numbers. What is this last formula used for? Maddox? Yeah, temperature. Yeah, changing Fahrenheit into Celsius. So if I wanted to know what 76 degrees Fahrenheit was in terms of Celsius, I would take 76 degrees Fahrenheit, subtract 32 from it, times it by 5/9, and that's going to give me the Celsius temperature. This 32 comes from the fact that when water freezes at 32 degrees Fahrenheit, in Celsius, water freezes at 0. Celsius is actually a lot easier to use. Water freezes at 0, water boils at 100. Celsius is completely based off of water. Fahrenheit, water freezes at 32, water boils at 212. Those are numbers that are harder to remember. 32 we probably have, because that's considered freezing when it's even outside. So in order to solve it for F, the first thing I'm going to do, well, I have 2 options. You could distribute the 5/9 of both terms. We've done that before. But we've also done a shortcut method. Do you remember what the shortcut method would have you do? You do a lot of shouting out, don't you, Carter? Divide both sides by 5/9. Dividing both sides by 5/9 will cancel out with the multiplying both sides by 5/9. So on the right side of the equation, we have F minus 32, capital F minus 32. And on the left side, we have C divided by 5/9. Now, when you divide a fraction, it is the same as multiplying by its reciprocal. So Garrett, what's the reciprocal of 5/9? 9/5. So C divided by 5/9 is the same as C times 9/5, or 9/5 C. Now to get F by itself, we have to add 32 to both sides. and we get this. 9/5 C plus 32 equals F. So I have one equation that's useful for turning Fahrenheit into Celsius. And then I've got another equation down here that's useful for turning Celsius back into Fahrenheit. They're inverses of each other. In fact, we're going to do that right now. What has the greater temperature? The sun at 11,000 degrees Fahrenheit or a lightning bolt at 30,000 degrees Celsius? I could either turn the sun into Celsius and compare, or I could turn the lightning bolt into Fahrenheit and compare. Since I did all that work to get an equation that helps me turn Celsius back into Fahrenheit, why don't we go ahead and do that with a lightning bolt? Let's turn the lightning bolt's 3,000 degrees Celsius into Fahrenheit by plugging it in for C. So 9/5 C, and for C, I'm going to plug in that temperature in Celsius, 30,000. I'm going to add 32 to it, and that's going to give me the Fahrenheit temperature. Timesing by 9/5. If I want to have my calculator help me out, which I definitely could do that, I need to know what 9/5 is as a decimal. It would help to know what it is as a mixed number. What's 9/5 as a mixed number? Sean? 1 4/5. So what's 4/5 as a decimal? Jace? 1.8. Yeah. So I've got 1.8 times 30,000 is another way you could do it using your calculator. Or we could have turned 30,000 into a fraction, putting over 1 and cancel, but let's just use the decimals here. What is 1.8 times 30,000? Go ahead, Brady. 54,000. I can already tell you what's hotter. Because if you add 32 to that, that's going to give me 54,032 degrees Fahrenheit. So a lightning bolt at 30,000 degrees Celsius is actually equivalent to 54,032 degrees Fahrenheit. Compared to the sun, about 5 times as hot. That doesn't seem possible, considering people have been struck by lightning and survived. Yeah, Jimmy? What's wrong? Yeah, so what we did is we converted this into Fahrenheit. Yeah, so now we're comparing 11,000 degrees Fahrenheit with 54,000 degrees Fahrenheit. We know that lightning bolt would be hotter. So I guess which has the greater temperature? You'd say the lightning. Questions?
Well, I was gonna say maybe people can survive lightning bolts. Something maybe it has something to do with oxygen. Like in space, there's no oxygen, but on Earth there is.
True. Yeah, or that by the time the lightning bolt gets down, it's lost some of its temperature. I don't know. Seems like it'd be. Yeah, Maddox. Yes, they're instant. And as quick as they show up, they're gone, right?
Yeah.
So I'm not exposed to that temperature for any severe length of time. Yeah. Your body can't survive 11,000 degrees Fahrenheit, let alone 54,300 degrees. Carson? Yeah, not the whole body too. Yeah. That's a good point. That's a good spot to end because that's the end of our notes. Your homework for tonight is 1.4. See you guys tomorrow. Yes, you need your work paper for your 1.4 homework.
This week we have a total of 3.